So during this training session, we're going to talk about the differences between helium and argon and how they're applied to the gas tungsten arc welding process, or otherwise known as a TIG process. So to get a real good understanding of the two gases, it's important to talk about a few of the properties of the gases. Two, importantly, the thermal conductivity of the gas and the ionization potential of the gas. So first, we're going to talk about the thermal conductivity of the gas. The thermal conductivity is basically how well the gas conducts heat outward from the welding arc. Argon has a very low thermal conductivity and helium has a very high thermal conductivity. When welding, you'll see this if you look at the inner cone of the arc with an argon shielding gas, you'll see that the arc cone in the center of the arc is very narrow, okay? Whereas helium, the inner cone is rather broad. So that's indicative of helium conducting heat outward, whereas argon does not do that. It has a very cool outer cone of the welding arc. So the difference between argon and helium has a much higher thermal conductivity. So it conducts heat outward much better than argon does. The next property that is important to understand between argon and helium is the ionization potential. The ionization potential is simply the conductivity of the gas. It can be thought of that way. So helium, as you can see from this chart, has a very high ionization potential, whereas argon has a very low ionization potential. So what this means is argon requires much less energy to become conductive, whereas helium requires much more energy to be conductive. So if we look at an argon atom and a helium atom, you'll notice that the helium atom has only 2 electrons circling around the nucleus, whereas argon has 18 electrons circling around the nucleus. For this reason, helium requires more energy to become conductive. Argon requires much less energy to become conductive. So what this will do for the welding arc is when you're welding, and we'll demonstrate this here in a minute, when we're welding at 100 amps at the same physical arc length, the distance from the end of the tungsten to the work, and we're welding with 100% argon, we will have significantly lower arc voltages than if we were welding with 50% helium or 100% helium because of the difference in ionization potential. This is one of the reasons that helium is thought of as a hotter gas, because of the higher arc voltages that are present when welding with helium over argon. So because of these properties, helium is a big advantage in some applications in the gas tungsten arc welding processes, especially when we're welding over copper or heavy aluminum, since those materials conduct heat rapidly away from the welding arc. So please watch these next demonstrations, and hopefully this will help illustrate for you the advantages of helium, and hopefully gives you a better understanding of how helium works in the welding arc. 100 amps, 100% argon, demonstrating the difference between argon and argon helium.
We just now got a puddle established, and now we're able to start traveling, and if we were adding filler metal, we would add filler metal.
That was 100% argon, and it took quite a while for the puddle to get established before I could start adding filler metal or traveling. In this case, we weren't adding filler metal because of the demonstration. Now I've got 50% helium, balanced argon, machine set at 100 amps. Take note of the arc and how long it takes for a puddle to get established.
Puddle's already established, and I'm able to start traveling.
So that demonstration illustrated the differences between helium and argon and 100% argon in the gas tungsten arc welding process. And so from what we've seen, we saw that with a helium-argon mixture, we had a higher arc voltage with helium-argon. We had a puddle that got established quicker, almost immediately, with the helium-argon. And we were able to travel faster with the helium-argon. All at the same amperage and physical arc length between the two gases. And I hope that helps you understand the differences in the two gases and how you can use helium as an advantage in your gas tungsten arc welding process.